Okay, we have another problem here. This is from my math lab. It's a test for a disease. And in the problem, it says that 95% of the time, patients test positive for the disease, and it's correct. 90% of the time, the test it gives a negative result, and it's correct. So let's make a table for this, saying two columns. We have D means we have the disease, ND means no disease. And a P is positive and an N is negative. So working this out, we're going to start with a positive result where you have the disease is 95% of the time. So here we have positive, have the disease, so right here is 95. We want to put a 95%. 95% of the time we have the disease and it's positive, which means that the test positive with not having the disease would be the remainder 5%, because 95% plus 5% is 100%. Now in the next row, we have negative results. The negative results are correct 90% of the time. So our 90% goes here. It is negative 90% of the time when in fact we do not have the disease, which means 10% of the time it comes back negative and we have the disease. Okay, now I'm going to make another chart. Again, this time I'm going to have, again, positive, negative, but this time I'm going to put the number of people having the disease and not having the disease. And we're going to use, imagine that we have 10,000 people. Okay. So 10,000 people in our sample. So if we have 10,000 people in our sample, we want to know, to fill in each one of these, that first of all, we want to know how many people have the disease. Well, the incidence of the disease is 1%. So we want 1% of the people. So I'm going to put that into my calculator, and that's 0.01 is 1% times, and really it's moving the decimal place, 10,000, and that should give us 100 people. So we have 100 people have the disease. So 100 people have the disease. And if 100 people have the disease, well, 10,000 minus 100 is 9900. These people do not have the disease. So 990 people do not have the disease. So let's put that in here. So what I'm going to do is I'm going to put the lines for this table to see a little bit better here. And I want to look in the columns. It's not the most straight lines here. Okay, our first column are the people with the disease, and there are 100 people with the disease. So I'm going to write that in here. There are 100 people total with the disease, and of those 100 people with the disease, some will test positive for the disease, some will test negative. Now there are 9,900 people that do not have the disease, and some will test positive and some will test negative. So let's first work with the 100 people. Of the 100 people, remember, 95% of that 100 will test positive. So 95% of 100 is 95. So 95 people out of the 100 will test positive for the disease and actually have it. And then the remaining 5 people out of that 100, which is 5%, will have the disease but test negative. Now we have to fill in this column here. In this column we have 9,900 people do not have the disease. Some will test positive and some will test negative. Well, 5% of this 999 people will actually test positive. So I'm going to multiply 0.05, that's 5%, times 9900 on my calculator, and I get 495 people who do not have the disease. Oops, let me fix that. 495 people do not have the disease, but they test positive. And then the remaining people, I'm going to subtract 495 from 9900, and the remaining people, 9,405 people, test negative and in fact do not have the disease. So if we look at this, if we add these two together, the 95 and the 495, if we add together 95 plus 495, we get 590. So we have 590 people total test positive. Some have the disease, some do not. And then if we add together the 5 and the 9,405, I'm going to do that in my calculator. Well, I don't have to do that in my calculator. That's 9,410. And if you add up the 590 and the 9,410, we get the full 10,000 people. And if we add up the 100 and the 9900, again, we get 10,000 people. So what I have here is this chart that helps us answer the question. If a person tests positive, what is the chance the person has the disease? Well, for positive, there are two possibilities. Either 95 of our 10,000 people test positive and have the disease. 495 people test positive and do not have the disease. So a total of 590 people will test positive. So of the people who test positive, right? Because if a person tests positive, what is the chance the person has a disease? Well, here, let me circle this. Here's the total number of people who test positive. Here's the total number of people who test positive and have the disease. And we have, if a person tests positive, here they are, they're all the positive people. What is the chance the person has the disease? Here are the ones who have the disease who test positive. So we want the ratio of 95 over 590. And if I put that into my calculator, 95 divided by 595, and I get 0.159. So what I'm getting for an answer here, I'll put it here, is 0.159, which is approximately 0.16, which we can say that is 16%.